All right, so we've come to the end of the chapter. We're on section 8.4, proportionality theorems. So let's get rolling right here. We have a few terms to start off with. It says, write the meaning of each vocabulary term. Corresponding angles. Those are, hopefully you'd realize, are angles from like two triangles that are in the same location. Ratio. A lot of times when we talk about ratio, you could write it either as a fraction. So that's one thing that I think about with the ratio is you could write things as a fraction. But what you could also do right here is write things as using using the colon, like A to B. Okay, so there's two ways for us to take a look and think about a ratio. When it comes to proportion, typically proportions, we've written them as something that looks like this, where we have two fractions that are equal to each other. Okay, so think right here, equal fractions. For example, like 1/2 is equal to 2/4. Okay, so those right there would be an example of a proportion. So we use proportions right here. I guess it takes us to our theorem 8.6, our triangle proportionality theorem. And we could use this if a parallel line to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So what they're saying is that, look, if I have right here two lines that are parallel, right? I've got QS, I've got TU, right? Those two lines happen to be parallel. Then we can go ahead and say that RT over TQ. Okay, so I think the important thing here to realize that when we do come up with these proportions, let's stick with the same side. So I have two colors there, right? I have TR in yellow, QT in green. That's equal to RU, which happens to be on the bottom side of this triangle, over S to U. So when we put things together, the proportion, think same side, okay? The numerator is like the top side, the denominator is the bottom side of the triangle in this instance. Or it could be the left side and the right side, right? So that's one way to divide right here the proportions. If you're saying, why are they in those certain spots? So now let's go to the converse. Remember, we've talked about this so many times throughout the year. We changed the if-then statement. So now it says if a line divides the two sides of a triangle proportionally, then it is parallel to the third side. Okay, so pretty much what they're saying, look, if these sides are congruent, or sorry, proportionate, so like TR and QT, if they're proportionate right here, and that is equal to RU over US, then what we're saying finally at the end is that QS right here is parallel to TU. Okay, so we have ourselves some parallel lines. And that's the bottom line right here. We go to the next theorem, theorem 8.8. We have three parallel lines theorem. So I've got three parallel lines, okay? And you can see right here, R, S, and T, those are the three lines that are parallel. They intersect two transversals. Okay, so it's very interesting, I guess, in the fact that we have two transversals instead of one, and they divide the transversals proportionally. Now, how do they divide the transversals? Oftentimes, students they'll look at like line R and they'll think, oh, how about U to V, and look at line S, they'll think WX, and T is YZ. No, that's not how to look at things. Okay, so how do I look at it? We've got ourselves UW. You look along the transversal. Okay, UW over Y WY. Remember, they're on the same side or the same transversal when we come up with this. And then that's equal to Vx over XZ. Okay, so once again, I'll highlight the sections and segments there. And it's set up so that the proportion is on over the same side. Okay, UW over YW or WY. They're on the same side, right, when we set up that proportion. So pay close attention to that and make sure you do that on our problems. Next up, we have Theorem 8.9. We've got the triangle angle bisector theorem. And so if a ray bisects an angle of a triangle, so we have ray CD, right? And what it's saying is bisecting the angle. It divides the opposite sides into segments whose length are proportional to the length of the two sides. So what they're talking about here is this. We've got AC, okay, and then we put that over right here, A to D. Okay, so we've got our proportion. We've got the sides right here. And then we also have right here, okay, C to D. And then we have C to B. All right, so AD over DB, and then we've got CA over CB. So if you take a look, AD and DB right here, I'll circle it with red because those are the two parts or the two sides. And then CA and CB right here, I'll circle in blue. So you can kind of see, all right, what are the sides and how are they set up in our proportion, okay? AD over DB and then CA over CB. CA and AD, those are like, think about it, they're right next to each other in the on the triangle. So that's one way you can think, all right, how do I set things up in my proportion right here, okay? And the same goes for that DB and CB. They're adjacent to one another. And that's how you could put them in numerator, denominator. So let's take a look at our extra practice right here. So it looks like we need to find the length of segment AB. I've got two parallel lines. And AB right here, what I'll go ahead and do is let's go ahead and put that as X, okay? Because that's what we're trying to find. So putting this all together, we want to set up a proportion. Remember, we're talking about, let's set things up on the same side. So if I look at A to C, along that we have AB, which is X, and I'll put over 6. Okay, they're along that same segment. Let's take a look at this other side right here from A to D, okay? What I'm going to go ahead and put first now is 5, because 5 is along the same triangle as X or AB, right? And then for the bottom part right here, let's go ahead for a denominator, we're going to put 10. So pay close attention once again. Where are these segments being put in our proportion? I try to put them on the same side, okay? And then set them up. Numerator, denominator, same side, the two segments, and the same with the other sides. So we'll go ahead now, we'll cross multiply. I've got 10x is equal to 30, and then x, divide both sides by 10, x is equal to 3. Now, always go back and make sure you check to see if you answer the problem. This problem says find the length of A to B, and sometimes if there's an expression in for that segment, then you got to take x and plug it back in. In this instance, there's nothing really to plug in, so we go ahead and say AB is equal to 3. All right, let's take a look next up again right here on number 2. So I look on the same side, I've got AB. We'll go ahead and put that as x. And we've got over here, we've got segment BC. So those are on the same side. So I'll go put x over 7, and we'll set that equal to e to d over dc. E to d is 2, d to c is 9. Okay, and I put 2 on top because it is right across and it's on the same segment or section as where segment AB is on the triangle. So now we'll go ahead. We can go ahead and cross multiply, and I've got 14 is equal to 9x. We divide both sides by 9 right here, and x is equal to 14 over 9. And that's okay. We can leave it as an improper fraction. All right, so go ahead and do so right there. Leave it as an improper fraction. All right, let's go ahead and move along. Take a look at number 3 next. We want to determine, is segment AB parallel to XY? So think about the converse, right, to the triangle proportionality theorem, is that we got to figure out, well, are things proportional here? If they are, then they happen to be parallel. So I am looking right here. Once again, we've got z to a and a to x, excuse me. And on the same side, on the right-hand side, is 4 over 5. Okay, so when I set this up, I'm going to put 3 over 4 and set that equal to 4 over 5. And 3/4, that's 0.75. 4/5, that's 0.8. They're not equal to each other. Okay, so what we've determined right here is they're not equal. So that means not parallel. Okay, simple as that. Remember, they have to be proportionate in order for AB to be parallel with the third side, XY. Okay, so let's try this again with number 4. Let's see if we have better luck here. We have ZB over BY, so we got 6 over 4, and we'll set that equal to, over here, ZA is 7.5 over 5. Hey, if you can't figure out, what those numbers are because they're fractions and they're improper, then go ahead and just use your calculator. 6 over 4 ends up being 1.5. 7.5 over 5 is also 1.5. So what does that tell us? That AB is parallel to XY. We could say yes. All right, moving along. All right, so it looks like we got a lot of things going on here. We got 3 parallel lines. We've got, and then a transversal right here for problems 5 through 7. So I think it'll be easiest if you go ahead and start, like, maybe shading in the side. And so on number 5, it says UV is over WU. Okay, and WU or UW happens to be this whole entire thing. Okay, so let's see what happens on the other side. That's equal to XY. And then logically for me, well, since U to W is 2 segments on the left side, we're going to have to set this equal to XZ right here. And there's your answer for number 5. Okay, so maybe if you shade things in, do some lines, squiggly lines, whatever the case may be, and then you can go ahead and erase it, or then you can go ahead and do what I'm doing on your notes. Okay, so there you have our proportion. It's always a lot easier if you could try to visually write things to help you out. We have, so let's take a look at number 6. We got XY. Go ahead and put blue right there. We have YZ, which is right here in red. Okay, so if I take a look on the denominator right here, on the right-hand side of proportion, I've got VW, which is, I'll put in red. So hopefully, if you take a look at it, the missing segment right here is UV. And that's the missing piece for number 6. All right. On number 7, I've got blank over ZY. Okay, so let's see. ZY is right here. Let me look at the denominator of the right-hand side. We got WV. All right, so I'll go ahead and put this right here. Make that. Now let's go back to U or WU. Where is WU? Okay, so WU happens to be the whole entire thing right here on the right-hand side or left-hand side. So it looks like what's missing right here is going to be ZX or XZ. All right, so we'll go ahead and put ZX, and there you have it. We figured out and we completed the proportion. If you could visually see it fast, then super. If not, you could do what I just did right here to help you answer the problem. All right, next up, let's find the values of the variable. All right, so we've got some things right here to take a look at. This follows along line with the triangle angle bisector theorem, right? So we have a ray that's bisecting the angle, and so that tells us that we can go ahead and split up our proportion in a certain way. Well, how can I split this bad boy up? All right, well, let's think right here. We've got this side is 9, okay, and then we're going to have the two sides on one side of my proportion. And then what's a little bit different right here is that we have that third side as another side of our proportion. Okay, so I'll go ahead and write this. I'll put this as 9 over 15. And that's going to be equal to x over 5. The reason why I put the x on top for my numerator is because it's on the same, it's adjacent to that 9. All right, so we got 9 over 15 is equal to x over 5. And so simply, we'll go ahead and cross multiply. I've got 15x is equal to 45. Divide both sides right here by 15, and x is equal to 3. And there is the value of the variable. All right. So let's repeat this on number 9. Now, number 9 is not as easy as what we just did on number 8. There's a little bit more work. Maybe you could figure out why. So once again, I'll look at my triangle. I've got my two sides right here, and then the side opposite of the bisecting angle, which happens to be 14. But they never told us anything about, we never saw anything in the examples that were in regard to like the entire side. Well, what do I do here? Well, one thing I do know is that one of the segments is B. What I typically need to know is how long the other segment is in my proportion. Well, since they didn't tell us what that segment is, I'm going to have to come up with an expression that represents that. And what was that expression? You've done stuff like this in Algebra 1. I'll let you think about it. Okay. This expression that we need right here that represents that segment right there that I just drew out, that segment is going to be represented by the whole entire segment of that side of the triangle, 14, and then we'll subtract B from it. And so that right there represents that segment that you just see. And you may have just heard that train run by. Don't worry about it. Okay, so let's go ahead and we'll put our proportion together. So we have 6.75. We'll put that over 9. Okay, we'll put the two sides over each other. And remember, that part is always critical. Okay, and then let's go ahead right here. Let's set this equal to, for my numerator, I want to put that 14 minus b. And then put that over b. So now let's go ahead, we'll cross multiply, solve things out. I've got right here 6.75b, and that's equal to 9 times 14. And let's see here. That happens to get us 126 minus 9b. So let's go ahead, we'll get b by itself. So I'll add 9b to both sides right here. And so that'll get me what is that? 15.75b is equal to 126. Now I'll take 126, divide that by 15.75, and I get, this time, b is equal to 8. All right. So if you can figure out, hey, where do I put my segments into my proportion, that makes this so much easier, okay? And because sometimes what you'll end up doing is you'll do it one way, you know, you'll set up your proportion one way, you find out, hey, maybe I can set up my proportion another way and get the answer, and then you just get all confused. It becomes a big old mess, which we don't want. So make sure, try to be consistent when you do this, and you should be pretty good to go right here in chapter 8. All right, thanks for watching, and if you have any questions, feel free to ask.